Hello, could you please confirm that you can see me, you can hear me, as well as you can see the presentation?
Yeah, you are audible.
Okay. Okay. So, good afternoon, everyone. My name is Ambuj. I am a research scholar at Agricultural and Food Engineering Department, IIT Kharagpur. And I'll be taking your live interactive session for the course Farm Machinery. What we will be doing in this particular session that I'll pose some of the questions based on the previous week's content in front of you, and you have to just comment the correct option based on your knowledge in the comment section, and then afterwards we will discuss. Okay. So the very first question for the day is this one: an inclined plate type metering mechanism has been tested to check the placement of corn seed on a sticky belt method type seed uniformity system. On the basis of test results, it was found that the miss index of the metering mechanism is 4% and the multiple index is 3.5%. What is the quality of feed index? Okay, just try to solve this particular question. It is based on the previous week's content only. Just try to solve. Rest we will discuss. Do try to solve this particular question. Here, as you can see, miss index is given, multiple index is given. Now, quality feed index that is being asked here. Okay. If you don't know the formula, I'll just tell you. The quality feed index is equal to 100 minus in bracket metering miss index plus multiple index. Yes. Yes, Pradeep Kumar is saying 92.5. Great. Okay. Very good. Yella Swami, please, you also try. I already told you the formula also. Okay. To try to solve this particular question. The formula is 100 minus in bracket miss index plus multiple index. Okay. Easy question. Do try to solve. Check what is the answer coming. Yes. Very good. Both the students have just calculated. Very nice. The correct option is 92.5 only. Okay. This particular option, as you people have calculated, I'll just brief you about what are the different indexes. Okay. Miss index. First index is miss index. It is a measure of how often the seed metering mechanism fails to release a seed at a designated time or position. As from the name you can see, it is miss index. Okay. Essentially, it indicates the percentage of planting instances where no seed is getting dropped from the metering mechanism. That is why the name has been given miss index. Okay. Now, how to interpret this particular index, miss index? Okay. Lower the miss index would be the uh, a more reliable metering mechanism would be there. Okay. Lower the miss index is, the reliability of our metering mechanism will increase. Okay. Because fewer gaps would be there in the seed placement. Okay. High miss index means high frequency of missing seeds leading to uneven plant spacing. Okay. So this is the interpretation of the miss index. Another index in this particular question was multiple index. Okay. As the name suggests, multiple index measures how often the seed metering mechanism releases more than one seed. Okay. The designated time or position. Okay. It represents the percentage of planting instances where multiple seeds are getting dropped. Okay. In the same spot. That is our multiple index. Okay. What is the interpretation? How to interpret the multiple index? Lower is the multiple index, the better is the precision in the seed placement. Okay. With fewer occurrences of multiple seeds being dropped together. Higher is the multiple index, higher is the frequency of multiple seeds. Okay, which results in overcrowding and competition among the plants. Okay, if at the same place two or three seeds would be sown, what would be there? They all will germinate and they will have a competition for the resources. Okay, so that will ultimately lead to yield reduction. Okay, just for your information, what is the interpretation of multiple index? Okay, three indexes, and the next index was quality feed index. Okay, it is a comprehensive measure of seed metering mechanisms performance. Okay, represents the percentage of planting instances where seeds are placed accurately. Okay, we are measuring the accuracy of our metering mechanism. Okay, and both of these are inefficiencies. So, how to interpret or how to make the formula 100 minus misindex plus multiple index? If both the values are in percentage, okay, then you have to subtract from 100. Okay, 100 percentage minus misindex plus multiple index if both are in percentage. But in the question, you might be given it in fractions. So what you will do? 1 minus misindex plus multiple index. Okay, if both the values are given in fraction. Okay, like misindex might be given 0.405 or 0.0405. Okay, or multiple index might be given 0.02. Okay, so 1 minus the sum of both these values. Okay, this is the interpretation. Yes, what is the interpretation? This was the formula. What is the interpretation? A high quality feed index indicates overall better overall performance of the my seeded metering mechanism. Okay, seeds are getting placed correctly at the desired spacing. Okay, lower QFI, lower quality feed index suggests more frequent issues. Okay, with either the missing index or multiple index being dropped together. Okay, sorry, screen not visible. Okay, uh, here I am using two particular screens. If Pradeep can just confirm that his screen is visible or not, okay, then I'll just rejoin. But
The screen
yes,
is visible.
yes. The screen is visible. Yellow for me. My request to you is please rejoin. Okay, leave once again, once, then rejoin. Okay, then I think the screen can be visible to you. I'll wait for you. Okay, no problem. Yes, yes. Is it visible to you now? I am waiting for you. No problem. Okay. Yes. Now okay. Okay. Yes. Sometimes there is problem in network. That is why this problem happens. No problem. Okay. You can always leave the meeting and join once again. Okay. Problem will be solved. Actually, I am here at this place. I am using three particular screens. Okay. From one, I am just writing. Okay. With the help of stylus, that is tab. Another one I am recording. Okay. And another one is laptop. There I am monitoring how the things are going on. Okay. So whenever things uh, get out of my control, I always know. Okay. Yes. We will continue. Yes. I was telling you about the interpretation of quality feed index. Yes. Higher quality. Yeah. Hi, sir. One doubt how to get the material for examination. Yes. As you have enrolled in the course, the place from where you are just viewing the lectures of Professor V.K. Tiwari, sir. Okay. At that place only, you will be having the lectures combined as well as all the material. Transcripts are also there, I think. Okay. Along with this, the I am taking your live interactive sessions. I have already provided you the link. I'll just pin it. Okay. Yes. I think you can see the presentation and lecture recordings are present in this Google Drive, Google Doc link. Okay. Yes. This all is the material. The lectures which are taken by Professor V.K. Tiwari sir and the live interactive section which I am conducting. Okay. The recordings as well as the presentation. Everything is present on this Google Docs link. Okay. I think it is visible to you. Otherwise, I'll just post it once again also. No problem. Okay. Yes, we'll move forward. Yeah. Higher quality feed index indicates better overall performance of my seed metering mechanism. Okay. Seeds being correctly placed, okay, at the desired spacing. It should be higher. Quality feed index should be overall higher. Okay. Miss index in multiple index in a seed metering mechanism should be lower. Okay. Lower quality feed index suggests more frequent issues which emerge with either missing seeds or multiple seeds. Okay. That is the interpretation. Yes. As you can see here, I have solved also quality feed index 100% minus miss index plus multiple index. You people also have solved. So miss index is given 4%, multiple index is given 3.5%, 100 minus the sum of these two, 7.5%. It is 92.5%. Yes. Any doubts in this particular question? Anything you want to ask regarding this question? If not, then please do tell me. We'll move forward towards the second question. Clear? Please do type. You are clear, you are not clear. Anything will help. Are you clear?
Yes, sir.
Okay, okay, okay. We'll move forward. Yes. A self-propelled 8-row paddy transplanter operated at speed of 4 kilometers per hour is used for transplanting the seedlings at a row spacing of 15 centimeters. If the total time loss is 15%, then what is the actual time required to cover an area of 3 hectares? Please do solve this particular question. It is related to actual field capacity, theoretical field capacity. Okay. Uh, some modification is required. Please do try to solve. Okay. I'll give you enough time, 5 minutes. After that, I'll tell you the detailed solution. Theoretical field capacity is speed multiplied by width of the implement divided by 10 in hectares per hour. Okay. This is theoretical field capacity. Okay. Actual field capacity is equal to what you can just write theoretical field capacity multiplied by field efficiency. Okay. Or you can say field efficiency is equal to actual field capacity divided by theoretical field capacity. Okay. Yes. Using these two particular formula. Okay. You just try to solve this question. And field efficiency is T naught divided by T naught plus TA plus TH. Okay. All the losses we have incorporated here. Okay. Yes. Try to solve. T naught is theoretical time. Okay. Which is required to cover a field, and TA is time losses proportional to area. TH is time losses non-proportional to area, like filling of the hopper. Okay. And TA includes turning losses. Okay. And T naught is the theoretical time. The entire formula for field efficiency is T naught upon in bracket T naught plus TA plus TH. Okay. Yes. Okay. Okay. I think you are just trying to calculate. Okay. I'll tell you the approach. No problem. Okay. The correct option is 7.35 hours. I'll just tell you the approach. Okay. How to get this particular question correct. Okay. First of all, I'll calculate the field capacity, theoretical field capacity of the transplanter. Okay. That will be S into W divided by 10. Okay. I already told you the formula. Then 4 multiplied by 1.2 divided by 10. What I'll be getting? 0.48 hectare per hour. Okay. Then what would be the time which is required to cover 3 hectares of land? Okay. It is already mentioned in the question. If the total time loss is 15%, then what is the actual time required to cover an area of 3 hectares? Okay. So for 3 hectare area, I'll just divide it by my TFC, theoretical field capacity. Okay. Always check for the units. 3 is in hectares, hectare divided by hectare per hour. Okay. So the final time which I'll be calculating, which I'll be getting would be in hours. Okay. So 3 divided by 0.48, that is 6.25 hours. Okay. Now the time loss is 15%. Okay. So what I'll be doing, either I have to divide by 1 minus the loss. Okay. That is 1 minus 0.15. Okay. That would be equal to 0.85. Or another approach for this question, I'll just calculate, see here the step number 2. Okay. I'll just calculate effective field capacity, TFC, theoretical field capacity, multiplied by 1 minus time loss. Okay. Either I have to multiply or I have to just divide by 0.85. Okay. Better you go with this particular approach. Don't get confused between the two approaches. From both, you will be getting the same answer. Okay. But for the examination point of view, this is particularly easier. That is why here I have kept this particular approach only for you people. Okay. Calculating TFC, then calculating the time required to cover 3 hectare land. Okay. Time loss 15%. Okay. Divided by the efficiency, that would be equal to 1 minus the loss, that is 0.85. Answer would be 7.35. Is it clear? Is it clear? Any doubts? Please do respond.
Sir, please repeat the solution once again.
Okay. I'll just repeat. Okay. See, here in this particular question, 8 row paddy transplanter is there. Okay. Speed is given 4 km per hour. Okay. And the row to row spacing is given 15 centimeters. Okay. So the formula for theoretical field capacity says S multiplied by W divided by 10. Okay. So see here, 4 multiplied by the total length would be 8 into 15. Okay. In uh, S is in kilometers per hour. Okay. W is in meters. So here it would be total width of the implement. Okay. That would be 8 multiplied by 15. Okay. Since 8 rows are there. Okay. And 15 is the spacing, row to row spacing. Okay. Total it would be 8 into 15. It is 1.2 meters. Okay. And losses are given 15%. And what I am asked, what is the actual time required to cover an area of 3 hectares? Okay. Yes. So field capacity, I have just calculated 4 multiplied by 8 multiplied by 15, that divided by 100. Okay. Why? For getting the W in meters. Okay. So 4 multiplied by 1.2 divided by 10. The correct field capacity would be 0.48 hectare per hour. Okay. Then what is the time required for covering 3 hectares area land? That would be equal to 3 hectares divided by 0.48 hectare per hour. So in total, you will be getting 6.25 hours. Okay. Then that was the theoretical time. Okay. Actually, 15% losses are also there. Okay. So what I'll be doing, I'll be just dividing this particular value by 0.85. Okay. 1 minus the total losses, that would be the efficiency, divided by efficiency, that would give me the actual time requirement. Okay. Is it clear to you now? Any doubt is there,
Yes,
then
sir.
please do ask me. Okay. Okay. Great.
Sir,
We shall
alternate
move.
solution.
Alternate solution. Okay. Alternate solution is this one only. Okay. Here also same procedure I have just given. Okay. Theoretical field capacity is there that I have calculated. Okay. Effective field capacity I have calculated, that is coming 0.408 hectare per hour. 1 minus time losses, that here I have just multiplied by that. And then for covering the 3 hectare area, time is required. Okay. Time calculation is required. So 3 hectares divided by 0.408 hectare per hour. Okay. That is 7.35 hours. Both the solutions are there. They are both the same. Okay. Any approach you can just follow. Okay. Here just multiplication is there. There division is there. No particularly difference is there. Okay. Anything which suits you can follow. After the class, please do revisit the solution once. Okay. You will get a better idea when you will try to solve, see the question and solve the question yourself. Okay. Yes. Any more doubts?
No, sir. Got it.
Okay. Okay. Yes, we shall move forward. Okay. This is a practice session. Please do try to attempt. If you are having any doubt at any place, please do ask me. Okay. This session is designed for you people only. Be as interactive as possible. Do ask me. Okay. And unless until you are clear, don't let me go to next question or next slide. Okay. That is your responsibility. And getting your doubts cleared is my responsibility. Okay. So we shall fulfill each other's responsibility. Yes. A drum seeder is there in this particular question, is used for sowing the paddy seeds at a rate of 40 seeds per 1 meter length of the row. If the row spacing is 25 centimeter and the mass of seeds is 1000 seeds in 30 grams. Okay. Mass of 1000 seeds is 30 grams. Then the seed rate is given by 125 kg per hectare, 60 kg per hectare, 48 kg per hectare, or 80 kg per hectare. Please do try to solve. Okay. See, I'll just provide you hint here also. Okay. Seed rate, as you can see, unit is kg per hectare. So from this particular hint only, you can just solve this question. Okay. You have to calculate for a unit area how much quantity of seed is required. Okay. What is the mass of seed which is required for unit area? Okay. After that, what is the mass of the seed which would be required for 10 raised to the power 4 meter square area? Okay. That will give you seed rate. Okay. This hint I have given you. Okay. Please do try to solve it. I'll give you the entire solution. I'll explain you in detail. Yes. These questions are very common in GATE examination. Okay. As well as your university examinations also. Okay. These questions are very common. Please do try to solve them. Okay. Yes. Yella Swami, what happened today? Not answering the questions. What happened? You were very interactive in the, I think, previous to previous session. If you are having any difficulty, then please do ask me. Okay. I am here for you. Don't feel shy in asking the doubts, okay? Do ask, do clearly see the entire solution, okay? After the session, please do revisit these questions, okay? These are very good questions, okay? For the examination point of view, okay? Yes. Okay, I am sorry I was not able to see your comments. Very sorry. You both have answered to previous.
48 kg for a hectare.
Okay, very good, very good. Now I can see. My fault. I haven't seen your option. Yes, for previous question, Yella Swami says 7.35. Very good, very nice. And Pradeep has written, please repeat once again. Okay, I have repeated. Okay, no, clear, sir. Okay, very good. Yes, both the people have answered 48 kg per hectare. Okay, my bad. I was just, I scrolled it up. Okay, auto scroll is off in Google Meet. I don't know how to enter it. Yes, correct option would be 48 kg per hectare. Okay, now I will just keep a track of your comments. No problem. Yes, see here, solution I have provided you. Okay, number of seed per 1 meter length. Okay, is 40. Row spacing is 25 centimeters. Area covered to sow 40 seeds is area covered to sow 40 seeds. Okay, is 20.25 meter square. Weight of the 40 seeds is, what is the weight of 30 seeds? Then from unitary method, I got the weight of 40 seeds. Okay, that is 1.2 gram. Okay, very simple. 4.25 meter square area, 1.2 gram seed is required. Okay, so what would be the seed rate? 1.2, then divided by 1000, then 0.25, then divided by 10,000. 48 kg per hectare. Both the students who have joined today have calculated it. Very nice. Okay. Yes. I think you people are not having any doubts. I am assuming because both the people have answered. We'll move on forward. Okay. Yes. Now just try to solve this particular question. Okay. As per the IS 6813 to 2000, the seed and the fertilizer rate in a seed cum fertilizer drill shall be easily adjustable up to how many kgs per hectare. Okay, range is provided to you. Is it 175 to 1250, 150 to 750, 1000 to 500, or 125 to 1000? See, this whole thing is given in the lectures. Okay, I can understand. If you don't remember, please do just respond. Okay, there is no need to fear that you have to be correct in very first attempt. Then I'll show the code to you also. Okay, yes, try to respond. Yes, please do respond. There is not much calculation involved in this particular question. Okay, what's your thought on this question? I think D. Good, very good. Yella Swami says B. Pradeep says D. Good. Let us C. Yes, it is D only. Okay, 125 kg per hectare. Okay, do remember which is this particular code. Okay, 6813 2000. Okay, deals with seed and fertilizer rate in a seed cum fertilizer drill. Okay, this particular code is related to the design of seed cum fertilizer drill only. Okay, yes, this is the code. Okay, here I have shown the pictures. I'll zoom in, don't worry. Okay, after the class also in the PPT also it would be there. Okay, so please do see all the aspects which are there in this particular code. Okay, it is related to sowing equipment, seed cum fertilizer drill, and what are the specifications. Actually what happens now, those machines PPT will get separate, sir. Yes, you will get it at that particular link only. Okay, which I have provided to you. Okay, for pasting that link only I was not able to see your comments. Okay, I have given you, I think you can see that Google sheet. Okay, into that Google sheet you will get PPT recording everything. Okay, yes. Let us move here. What happens ni after the patenting of any machine? Okay, you have designed a machine, you have patented a machine. Okay, after patenting it goes into testing. Okay, various testing agencies are there in the entire India for agricultural machines. Okay, they test your machine. Okay, after the test some modifications are required. Okay, and after having those modifications, okay, you are now eligible for going of for your you are now eligible for just putting your machine into the market. Okay, so some standard machines are there. Okay, like this seed cum fertilizer drill is there, tractor is there, tire is there. Okay, bicycle is there. Okay, for every agricultural equipment as well as the other equipment some standards are made. Okay, I'll be making my seed cum fertilizer drill. Okay, so it should fulfill these particular criteria only. After that, only the government will allow me to sell my machine in the market. Okay, and who will check whether the standards which are set by the government agencies are getting met or not? The testing agencies. Various testing agencies are there. Okay. Yes. So for seed cum fertilizer drill, these specifications are there. Okay, let us see them. Okay, scope is there. Okay, then references, Indian standards is there. Then terminology they have given. They've given what are different types: animal drawn, tractor operated, trail mounted. Okay, then they have given the size also. Okay, size, what should be the size, how it should be mentioned. Okay, what are the different materials. Okay, for different type of uh, different parts, what materials should be used. Okay, it is not like that the hopper can be made from plastic. Okay, it will wear out. So some standards are there. Okay, that we have to follow. Hardness is there. Okay, what shall be the hardness, then frame and toolbar, how construction shall be made, then wheels, then axle shaft. Okay, then seed and fertilizer boxes, what should be the specifications. Okay, whether I should go for mild steel, whether I should go for GI sheet. Okay, depends on me. Yes, tines are there. Okay, what should be the specification? Okay, for openers. In this particular table, they mentioned what are the materials for construction of different components. Okay, after the class, you can just have a look. Okay, different for each and everything they have provided that which material we should use, that is written here in code only. Okay, you have to just go through that code. Okay, from there you will get what shall be the material. Okay, and what shall be the grade. Okay, yes. Next, yes, just a second. Yes, then see here, furrow openers are there. Okay, then seed and fertilizer tubes, what shall be the mechanism, what shall be the material, what shall be the specifications. Then metering mechanisms. Okay, then transmission system. Okay, then performance requirements. Seed and fertilizer rate shall be easily adjustable up to 125 kg and 1000 kg per hectare respectively. That was being asked in this particular question. Okay, so the entire code along with the detail I have mentioned here. Okay, Then percentage of visible seed damage. Okay, in the seed drill shall not exceed 0.5%. Okay, visible damage to the seed. Okay, which I can see while my seed cum fertilizer drill is operating. Okay, yes. Variation in dropping due to box filling, it shall be not exceed 10%. Okay, that is being mentioned here. What shall be the weight? Okay, what shall be the material? Okay, what shall be the accessories? Everything is mentioned here. Then workmanship and finish, then sampling and test, then marketing and packaging, then how to get that certification marking also. Everything has been mentioned here. Okay, after the class, please do revisit this entire code. Okay, I have mentioned here. You'll get a lot more insights. Okay, yes. Correct option would be 125 kg per hectare to 1000 kg per hectare. Yes. Let me just save this for you. Any doubts anywhere? Anybody? Any doubts? Clear? Not clear? Shall I move forward? Shall I stay?
Yes, yes, sir.
Yes. Okay. Okay. We shall move forward. Okay. Yes. Clear? Good. Very good. Now, please do try to solve this question. I know first three numericals were there. They were quite tricky, but these type of questions you can very easily solve. You should get always get 100 out of 100 in these questions, or 1 out of 1. Yes. A planter equipped with mechatronics system offers the benefit of optimum use of seeds, uniform seed rate application, easy seed rate adjustment, all of the above. Yes, Pradeep is saying D. Okay, very good. Yella Swami is saying very D, and you both are very correct. Okay, I congratulate you for getting 1 out of 1 in this particular question. Okay, yes. Yes, a planter equipped with mechatronics system offers all the benefits. These were the benefits: optimum use of seeds, then uniform seed rate application, then easy rate seed rate adjustment. Let us look at each of them. Okay, one by one. Mechatronics system integrates mechatronics. Okay, mechatronics, mechanical plus electronics. Okay, I'll just write so that your understanding becomes more fundamental. Mechatronics means mechanical plus electronics. Okay, electronics. Yes. The system would be having mechanical component, electronic component, as well as the components of control engineering. Okay. Enhance the functionality and precision of agricultural machinery. I'll tell you this particular uh, domain in great detail in the next few slides. Just be with me, okay? Because this particular domain is getting important day by day. Okay, if you will be doing some R&D research after this particular graduation or post graduation, as well as if you are going for higher studies, this particular domain is getting a lot of focus nowadays. Okay, so I'll tell you the components as well as how is it functioning in great detail. Okay, be a bit more careful, okay, as well as attentive. Okay, and do ask me if you are having any doubts. Okay, in the next few slides I'll be telling you in this particular domain in great detail. This is very important for your future. Okay, if you are getting in touch with this particular industry, okay, agricultural machinery industry, or you are pursuing higher studies, for both the domains this particular concept is getting a lot of attention nowadays. Okay, so be with me, be attentive, just focus. Yes, so both the components, all the components would be there: mechanical components, electronic components, control engineering components, all would be there in an agricultural machine. And how I will get optimum use of seeds? Okay, firstly I'll get these particular benefits. Do understand this. Okay, the precise control and the automation which is getting provided by the mechatronics component. Okay, everything is getting automated. Okay, here actually what thing is happening, feedback is there. Okay, So the efficiency of the system is getting enhanced. For example, I am teaching, okay, you students, okay. If I'll be performing monologue, okay, like in a fully mechanical machine, just compare, okay, with, my monologue with a mechanical machine. What would be there? Machine would be performing something, okay, some task would be performed by the machine. For our case, let us take the example of metering mechanism only. Okay, this class is regarding mainly regarding metering mechanism. That is why I am taking this example. Okay, so in my case, if monologue is happening, I am only speaking, you are only listening, then what is happening? Might be there some concepts you might be slipping. Okay, you might not be able to understand the concepts, or if you want me to repeat those concepts, you won't be telling me. Okay, so in this case, in first case scenario, monologue is happening. Okay, flow of information is taking place in one direction only. Okay, in the other case, feedback mechanism is there. I am telling also, okay, I am giving information you also, okay, I'm teaching you, as well as I am getting feedback from you also. Okay, so from the feedback I'll be correcting my approach. Okay, I'll be focusing, I'll be changing my voice, I'll be highlighting those things, I'll be using visual diagrams, I'll be using more examples. So in this way, now dialogue is happening. Okay, in first case it was monologue, in the second case it was dialogue. Okay, I am getting feedback from you people also, and I am adjusting my approach according to that. Okay, so this particular approach, okay, if you try to make an analogy with mechanical machines, okay, so in first case, my metering mechanism, in case of my metering mechanism, only monologue was there. The rotation is happening from the hopper, seed is getting dropped. In seed is getting dropped, then my metering mechanism is rotating. So in the cells, it is getting filled. Then from the cells, it is going to a seed tube. Then from seed tube, it is falling into the soil at the correct place. Okay, after the a strip of the soil is cut. Okay, this is fully mechanical system. Here no feedback is there. But in my mechatronics system, feedback is there. Some camera would be there. Okay, it would be seeing how many miss index is there, how many multiple indexes there. Okay, from the camera, a microcontroller would be there. Okay, microcontroller is micro plus controller. Okay, controller is something, some hardware component which controls something, and micro means small size. Okay, so in my tractor or in my equipment, okay, this particular seed cum fertilizer drill, okay, I cannot fit the entire CPU. Okay, it would be bulky also, it would be costly also. So some small microcontrollers are there. Okay, here I'll just show you an example of a microcontroller. If you see here, okay, this is an example of a microcontroller. It can perform all the calculations as well as the actuations, okay, which are there. Okay, it can perform the calculations also, it can perform actuations also of various mechanical components based on feedback, okay, from sensors. The name of this microcontroller is ESP32. Okay, you can just research about it. Okay, you can use this particular microcontroller in your BTech projects also, or PG projects, PhD projects, any projects. Okay, so first component was my sensing. Okay, either it is from camera, either it is from any infrared sensor, or various domain of sensors are there. Then I'll sense, then I should have a brain. Okay, so this particular component, okay, which is known as microcontroller, it is the brain. Okay, then after that some actuation would be there. Okay, adjustment would be there. If missing index is more than particular value, or multiple index is more than a particular value, then I'll adjust the parameters. So adjustment would be there. For that, some components would be there. Okay, like linear actuator would be there, or any actuation would be there. Okay, which will correct my approach. Okay, so these are the principal domains of automation. Okay, first component was sensing. Okay, another one was microcontrolling, another one was actuation. So my this particular mechanical machine became into a smart machine. Okay, This is the particular example of automation. Okay. Nowadays, this particular domain is getting a lot more emphasis. If you are appearing for any job interview in a company, you would be asked multiple questions regarding this. Okay. Because machines are already there in the market. Now automation is required. So how to automate? Okay. That particular domain, we will just look. Okay. Yes. So optimum use of seeds already is there. I have explained. Okay. Then consistent seed rate would be maintained. Okay. If something is getting disrupted, then loop is there. Okay. Closed loop is there. Okay. I am getting my feedback continuously. Then I'll adjust also. If my adjustment is wrong, then my sensor will tell me that your adjustment is wrong. You proceed in the opposite direction. Then I'll adjust once again. Okay. In that particular in this particular looping pattern, the optimum parameters would be reached. Okay. This is the thing. Then easy seed rate adjustment is there. Automated components are there. Either you can fully automate the process. Semi-automated control system is there. Okay. For accurate seed adjustment. So these particular incorporations, if we will provide in our machines, the machines will become smart machines. And these are the advantages. If you can think of any disadvantages of a mechatronic system, please do comment. Okay. In the between, I'll just move forward. At the end of this particular slides, 2-3 slides, I'll tell you the disadvantages also. If you can think, you can just comment. Okay. Yes. We shall move forward. This particular is the detailed analogy. Okay. Of a mechatronic system. From the very basic, I'll let you understand how a mechatronic system works. Okay. See here. In the B figure, the power electronics or actuator is there. Then DC motor is there. Then drivetrain is there. Okay. Then after that, pump is there. Okay. Pump is getting driven from a DC motor. Okay. This particular power flow. Okay. Diagram I have made. Okay. The representation of that is only there in first figure. That is in symbolic form. In the second figure, in B part, it is in more descriptive manner. Okay. Not in just symbol. And in the C figure, I have made the energy flow diagram. Okay. This is the design of a mechatronic system. Okay. In this way only, you have to design a mechatronic system. Okay. First, you formulate what are the components which are required. Then in the second phase, you just try to model what are the velocities, what are the currents, what are the angular velocities which are happening, how these components are interacting with each other in a closed loop. Okay. Important thing is everything should be closed loop. Okay. If it is not closed loop, then there is no particular benefit which I can achieve by incorporating these particular sensors as well as these particular microcontrollers in my system. Okay. Everything should be in a closed loop. Feedback should be there. Okay. If that is why at the end of every question I am asking you, is it clear, not clear? So in the next question, I'll change my approach accordingly. Okay. Try to prepare an analogy. Okay. And in the interviews also, if you are asked, then you can give these particular examples, which I am telling you right now. Okay. I am very sure from the last few years, okay, I think 3 or 4 years, those many number of students whomsoever are sitting for agricultural startups or agricultural companies, they are getting asked multiple questions on this particular system. Okay. Mechatronic system. Okay. That is why here I am covering it in great detail. Yes. Then in the C figure, you see the energy flow I have mentioned. Okay. The manipulated variables. Okay. They will be sent to the actuator, and sensors are measuring the variables. Okay. Looping is there. Here, see, looping is there. Okay. Even though it is not connected, I'll connect. Okay. No problem. For your understanding, I have connected also. Okay. Looping is there. Okay. First of all, sensors would be sensing. Okay. Then actuator would be actuating the mechanism. And then mechanics and energy converter are there. They are nothing but the microcontrollers. Three major components are there: sensors, microcontrollers, or mechanics or energy converters. Then actuators are there. They are the principal components of a mechatronics system. And closed looping is there. Okay, please do remember this particular keyword, closed looping. Okay, not open looping. Open looping is something else. Okay, in open looping the feedback is coming, but it is coming after a great interval of time. Okay, but in a closed loop mechatronic system the feedback is very fast. It would be in microseconds. Okay, that is the particular advantage of closed loop system. Yes. Then see here, this is the another detailed diagram. Okay, man machine interface is there, then information processing is getting happened. Then I already told you, from the actuator, here you can see the closed looping. There were components, here closed looping is there. Yes. Then you can see here the actuators, the mechanics and energy converter. Then sensors are there. Then we are measuring some particular variables. Then we are monitoring those variables also. It is not like that we are just measuring the variables. We are processing. Okay, we are seeing what variable is having uh, what impact on another variables also in a closed loop system. For example, changing my pitch or loudness of my voice will have what impact on my students. Okay, will they be able to better understand the concepts, or they'll be or they'll be covering their ears? Both of these are possibilities. So every possibility I have to check. So in the similar fashion, in a mechatronic system this particular closed looping is happening. Okay, yes. And these are the examples of mechatronic system. Basic principle already covered. After the basic principle, some examples of mechatronic system. Okay, like semi-active hydraulic dampers are there. You have to measure the hydraulic pressure, temperature. Okay, at the end, and on the basis of the load coming, I'll adjust the coolant. I'll adjust various other parameters. Okay, so that this system is also safe and the maximum efficiency of the system is reached. Similarly, automatic gears are there. Similarly, magnetic bearings are there. Okay, these are the machine components which you can pick. Okay, for your particular system. Then motion generators are there, like two servo drives are there. Okay, so there are two types of motors: stepper motors and servo motors. Okay, in our DC motor classification, which can be controlled through controllers. Okay, DC motor speed only we can calculate. Okay, servo motors are high torque, low torque motors. Okay, and stepper motors are high torque motors because they are having gear drive at the end. Okay, but servo motors can be very precisely controlled. Okay, and stepper motors, they move in steps. Okay, first step, second step, third step. These steps, number of steps you have to provide. Okay, but those are very high torque motors, and both of these motors can be controlled through microcontrollers. Okay, and the actuation is very precise, more precise in case of servo motor and less precise in case of stepper motor. But compared to the conventional DC motors, AC motors, synchronous motors, okay, asynchronous motors, every other motors, these two particular motors are having very precise actuation. That is why they are used in mechatronic systems. Okay, for making robots also servo motors are used. Okay, servo motors are used, they are controlled. Okay, for a robotic arm manufacturing you will use servo motors. And for end effectors, okay, the component which is there at the end which will perform some action, for those particular tasks stepper motor would be there. They would be requiring high torque. Okay, very high torque is required. Yes, yes, these are the examples of these are this particular motors. Yes. Mechatronic motion generators are there. Then robots are there. Integrated pneumatic devices there. Okay. Then see here, power producing machines. What are the power producing machines? BLDC motors are coming into the market. Brushless DC motors. Okay. These are the motors which will operate in a feedback loop. Hall effect sensors are these particular motors. For your general information only, I am telling you. Okay. Not necessarily this particular entire thing will come in the examination, but for from interview point of view and for your enhancing your knowledge, these are very important. Okay. Brushless DC motors are having Hall effect sensors. What is the benefit of Hall effect sensors? As my motor would be rotating, load would be acting. From the load, a feedback would be given to the Hall effect sensor. The Hall effect sensor will sense what is the load which is coming onto the motor axle, and it will adjust the current and power in voltage and current of the motor in such a manner that power loss would be minimum. This technology was never achievable a few years back. Okay. Nowadays, the fans are also coming with BLDC motors. Okay. Earlier, those motors were very costly, but nowadays, cost has also reduced, as well as the popularity of these motors has increased. Okay. Feedbacking is there. Okay. In this particular system, what is happening? Hall effect sensor is sensing. Okay. What is the load coming on the axle shaft? Okay. On the basis of the load or the torque, the V and I will be adjusted. Voltage and current would be adjusted in such a manner that the power loss would be minimum. Okay. Yes. Then integrated AC drives are there. Different AC motors are there. I'll connect them through AC drive. Okay. That AC drive will also operate in a closed loop. Okay. It will see that which particular system component is having the highest load. So it will try to distribute the load. Okay. That was never possible a few years back. Okay. These technologies are latest. From 2010 onwards, we are seeing a great progress in this particular domain. Okay. Worldwide. And India is also coming up with newer and newer technologies like this. Okay. Then mechatronic CI engines are there, combustion engines are there, combustion ignition engines or combustion engines are there. These are very intricate. Okay. At every step, sensing is there. Okay. Nowadays, the cars which you are seeing, they are fully automatic. Okay. They'll sense each and everything, whether you are sitting, whether you are sleeping, whether you are feeling somewhat drowsy. They'll give some alarms. Okay. These are on the sides of operator, but on engine side also a lot of things are there. Okay. That would be taught to you in a particular course of this IC engine. Okay. Yes. Then multi-axis machine tools are coming, hydraulic pumps are coming. In cars only, ABS is coming. Okay. Anti-brake, anti-lock braking system. It will sense automatically that whether the tire and the road surface interaction, okay, the friction which is there, if it is less than a particular value, then the brakes would be applied equally on all the four wheels of the vehicle. Okay. That is the basic principle of anti-lock braking system. Okay. Then electro-hydraulic brake is there. Similar type of components are there. Okay. But in case of electro-hydraulic brake, sensing would be there, and actuation of the hydraulic cylinder would be based on the sensing of the friction between the tire and the road. Okay. Then active suspension mechanism is there. Active front steering is there. Tilt training is there. Boogie, active boogie is there. Okay. Particular mechanism which is used in tram lines. This is a mechanism of active buoy. Okay. Try to search it. Okay. When you get time. Then similarly, maglev is there. The entire vehicle is getting lifted. Okay. By the principle of magnetic levitation. So it has to have a continuous feedback loop. Otherwise, based on the load, the current has to be adjusted. Okay. Current as voltage will remain constant in this particular maglev concept, but current has to be increased so that the EMF force, electromagnetic force, will increase so that the train can levitate. Okay. Yes. This was all from my side regarding the mechatronics system. Whenever you people get time, please do read this concept in great detail. Okay. This was all from my side regarding mechatronics system. If you are having any doubt, then please do ask me. Otherwise, tell me, I'll move forward. Okay. Is it clear? Everything clear? Any doubts? Okay.
Clear, sir. Clear, sir.
Okay, clear. Very good. Very good. Whenever you people get time, please do revisit this particular concept. Okay. All the concepts are latest in the market. Okay. These particular concepts are very, very important from interview point of view. Okay. As well as research point of view. From every point of view, these concepts are important. My sincere advice to you, please do not forget this mechatronics concept. Okay. Yes. Which of the following instrument is used for measuring rotational speed of the shaft? Please do tell me. Tachometer, potentiometer, spirometer, hydrometer. Okay. Do comment. A. Very good. Very nice. Yes. Instrument which is used for measuring the rotational speed of a shaft. Tachometer. From Yella Swami. From Pradeep, what is the answer? Is it potentiometer, spirometer, hydrometer, or tachometer? Tachometer. Good. Very good. Yes. The instrument which is used for measuring rotational speed of a shaft is tachometer only. Okay. It is specifically designed to measure the rotational speed of a shaft or a disc, typically in RPM. Okay. RPM is important. Revolutions per minute. Okay. It is commonly used in various mechanical and automotive applications to monitor engine speed and other rotating equipment. Okay. Another option was potentiometer. Potentiometer is an electrical component used to measure and adjust the voltage levels in a circuit. And what is the principle, working principle of potentiometer? Voltage divider circuit. Okay. It is not used for measuring rotational speed because tachometer is used for it. Okay. Already seen. Spirometer is related to medical field. Okay. It is used to measure the volume of air inhaled and exhaled by the lungs. Nothing has to, it has to do with our mechanical systems. Okay. It is used for measurement of volume of air inhaled and exhaled by the lungs. Good for your ergonomics course. Okay. Yes. It is not used for measuring rotational speed. Yes. Then hydrometer is there. Hydrometer is an instrument which is used to measure the density or the specific gravity of liquids. It is not used for measuring the rotational speed. Hence, the correct answer is tachometer. Okay. Here in this figure, two types of tachometers are there. First one is contact type tachometer. Another one is non-contact type tachometer. Which one will you prefer? Contact type, non-contact type? Please do tell me. What is your preference? Non-contact type. Very good. Another, Pradeep, which one will you like to use? Contact type tachometer, non-contact type. Very good. Both people will be going for contact type, non-contact type tachometer. Okay. Why? Because you don't want to have some contact with a rotational shaft. Might be you get hurt. Somewhat like this or any other reason. Yes.
For safety purpose.
For safety purpose.
Yes. Yes.
Okay. Okay. Actually, you can say it. No problem. Okay, but the real reason is accuracy. Okay, in case of contact type tachometer, asynchronous motor is fixed. Okay, when AC current is provided to your fan, what happens? Your fan motor rotates and it blows air and you feel cold. Okay, in case of a asynchronous motor, what happens? When you rotate that particular motor, then electricity is generated. So that electricity generation mechanism has to be calibrated with RPM. That is the basic principle of contact type tachometer. Okay, but the accuracy is somewhat less. Okay, in the second figure here, I will just write for those people who are not attending the class, they can also benefit. This is contact type tachometer. This one is non-contact type. Okay, good. Yes, for non-contact type, can you see this? What thing I am showing with my in my hand? Do you know what is the name?
Yes.
What is this called? This is somewhat like a sensor. Okay, it is having 3 wires. Yes. Do you know any guesses? Guesses can also work sometimes.
Something synchronous type.
No. Not something synchronous type. Okay. That I told you. Okay. Contact type tachometer. Okay. It is related to non-contact type tachometer. Okay. Any guesses? Even if you would have said that it is non-contact type tachometer, it would be correct only. Okay. This is known as proximity sensor. Okay. You will be using this in your BTech projects. That is why, or even your master's, PhD, any level. Okay. It is very important. That is why I am showing you this particular sensor. It is an industrial grade proximity sensor. Okay. It is having three wires. Okay. Uh, 2 wires are for plus and minus. DC current you have to supply. Uh, 5 to 12 volts. Okay. Anything between 5 to 12 volts, you can supply it. Okay. 2 wires for plus and minus. One is for signal. Okay. Have you seen it? I'll just keep it aside. Then I'll tell you how it works. Okay. What happens? A continuous beam of infrared rays is emitted from this particular sensor. Okay. And as soon as an obstruction comes in front of this sensor, you have to provide a obstruction. Okay. When as the shaft would be rotating, either you have to provide an extra attachment. Okay. Uh, Brief strip. Okay, metal strip you can provide, or any obstruction you can provide. A slot will also work. Okay, in the shaft. Okay, you as soon as my see, infrared receiver would be there, sender would be there, they will be having a closed loop. Okay, but as soon as the loop would be cut by this particular rotating shaft, that would be sensed by my proximity and a signal would be given. And in 60 seconds, how many number of times that obstruction is there, that will give me the RPM. That is the basic principle of basic working principle of non-contact type tachometer. Okay, I'll just repeat. I know it would be somewhat hard for you to digest. Okay, I'll just repeat. One infrared sender is there, one infrared receiver is there. Okay, in a non-contact type tachometer or in a proximity sensor, one infrared sensor is there, one infrared receiver is there. They are forming a closed loop. Okay, in and that particular closed loop shall be cut or shall be obstructed by a rotating shaft. Okay, that obstruction can be an attachment, that obstruction can be a metal plate, that obstruction can be a slot in that shaft. Okay, as many number of times my obstruction is coming in front of my closed loop infrared sensing mechanism, that many number of times has to be read in particular time duration, that is in 1 minute, okay, in 60 seconds, how many number of times my infrared sensing mechanism is getting obstructed, okay, that particular value will give my RPM. Okay, clear?
Yes, sir.
Okay, very good. This was regarding tachometer. Okay, yes. Let's move to the next question. Which of the following is not a method of implementing the site-specific information, okay, to the VFR, variable fertilizer rate application system? Okay. Yes, you are saying B, formula-based approach. Okay. Another option was sensor-based, then map-based approach. Okay. Yes, you are very correct. Correct option is formula-based approach. Let us look at this particular question. Okay. Method that is not typically implemented with a site-specific VFRA, variable rate fertilizer application system, is formula-based approach. If I will be going with the formula-based approach, then how I will be able to vary the fertilizer rate application? Okay, does not make any sense. That is why this option is incorrect. Another option was sensor-based approach and map-based approach. Yes, these particular approaches are valid approaches for VFRA system, variable fertilizer rate application system. Okay. Yes, brief information is here. Another detailed information is next few slides. Okay. Sensor based approach. Yes, this method use real time sensors to detect the soil properties, crop conditions, other relevant parameters directly in the field. Data which is collected, okay, from that data I'll be making a particular map, okay, that I have to geotag. There is a particular keyword, geotagging, that technology is used, okay. From that particular map, okay, I'll be able to vary the rate of fertilizer application. First of all, sensing has to happen, then mapping has to happen, okay, that these two have to be just integrated, okay, for variable fertilizer rate application. Okay, I know you require some clarification. I'll just repeat once again. Yes, this particular sensing method, first of all, sensing, what is sensing, then what is mapping? Yes, sensing uses real time sensor. As my vehicle would be moving, then soil properties have to be sensed, okay, crop condition has to be sensed, then the calculation has to be made that what is the quantity of fertilizer that has to be applied, okay, and that dynamically has to be changed for varying the fertilizer rate application. Another thing, map based approach, you just pre-collect the data of the entire field, either from soil sampling, either through yield mapping, okay, you try to just create a wholesome map of the entire field, then you guide the entire system through that map. How it is done, let us look. Formula based approach will not be a appropriate approach, that is clearly mentioned. Yes, much greater detail is shown here in this figure, okay, try to understand. Here you can see tractor is there, then variable fertilizer rate applicator is there, okay, controlling unit is there, okay, then a GUI is nothing but graphic user interface. It is a particular software, okay, it is there which will give all the outputs, as well as it will also take the necessary inputs from the user, okay, then GPS moduling is there, okay. So what will happen in this particular map based approach, okay, the entire field would be mapped, okay. First of all, before the mapping, okay, before the mapping, the soil conditioning or soil sampling will be happening, okay. So proper soil sampling at different places would be there, so you can have a map which would be having GPS coordinates and the relevant fertilizer quantity along with it, okay. So as soon as my tractor would be approaching that particular point, so the GPS coordinates would be matching, okay. I have already calculated, I have fed in the system, okay, what is the fertilizer quantity at which particular GPS coordinate. For example, at 00, 10 kg per hectare would be the rate. Okay, at 0, 1, 20 kg per hectare would be the rate. Similarly, 0, 2, 15 kg per hectare would be the rate. So for the whole field, I have created map beforehand only. Okay, not at the time of application, beforehand through soil sampling. Okay, then that map I have to feed in my system, and when my tractor would be going into the field, then at that particular GPS coordinate, that much quantity of fertilizer application will take place through my variable fertilizer rate applicator. That is the map based approach. Another approach was sensing approach. Okay, so here in this figure, you can see all the components of the sensing approach in great detail. First of all, see here in the top left corner. Okay, top left corner, eye color camera is there. Micro eye color camera is there. Means it will not be seeing things like we are seeing. Our eyes are an example of RGB camera. It would be micro eye color camera, means it will have various spectrum. Okay, various spectrum, so it will be able to see things in much greater detail rather than our eyes. Okay, we can only see RGB. A plant would be dying, then we will say that if we our eyes can see, then we will give water. So that is the power perception of RGB camera. Okay, eyes are example of RGB camera only. But when you go through hyperspectral camera, so a lot of bands you can see. So from those particular bands, you would be able to tell beforehand only that when a plant will die. Okay, beforehand only symptoms, 2, 3, or 4 days beforehand only, you would be able to tell that whether my plant is having a nitrogen deficiency, potassium deficiency, or any other deficiency. Okay, as well as if it is dying from lack of water or some micronutrient is less, what problem is there with my particular crop, that you can see with this particular camera, because various bands are there. Okay, research is going on this particular field, and a lot success has been already obtained from the year 2014 onwards. Okay, these particular satellites which are launched into the space, okay, they are having very high resolution hyperspectral camera. Okay, for our farmers only those particular satellites are getting launched. Okay, so beforehand only very accurate soil maps are there. Okay, they are already there. Okay, so from those soil maps I would be able to tell that a particular place, for example here in IIT Kharagpur, a field, okay, which is having those particular GPS coordinates, what is the lack, what is the deficiency. Okay, so similarly I will be able to provide nutrients to my field. Okay, first component I have explained to you. Then you see accurate controller, Rosen accurate controller is there. That particular controller is for guidance. Okay, then ruggedized laptop is there. This is a old system. Okay, from 2014, in the initial years only of the automation, these particular systems have come up. Okay, ruggedized laptop is nothing. Okay, it is a laptop which is steel frame. Okay, steel framing is there, means the laptop which is mounted on a frame. Okay, so that the vibration, it does not affect our laptop, as well as it becomes somewhat rugged, as the name suggests, ruggedized laptop. Okay, it will be having that GUI. Okay, as well as the controlling, so the operator can see. He has to just see, he does not have to drive while he is seeing the laptop. Okay, that might lead to some accident. Okay, that is just for his observation, that whether things are happening correctly or not. Okay, then see here 8 channel VRC is there. VRC is variable rate controller. Then just opposite side to that, PLC is there, programmable logic controller. Okay, that is the full form of PLC. That is also a type of computer. And VRC is variable rate controller. Okay, you can vary different types of controlling mechanism using VRC controller. Then auger system is there. Okay, the pneumatic cylinders are there and solenoid valves are there. Both of these, if you will just vary the pressure in the pneumatic cylinder, the opening of the solenoid valve will change, and that will change the amount of fertilizer which is getting applied in the field. Okay, so this was regarding both the approaches which were there in this particular question: sensor based approach as well as the map based approach. Okay, clear? Or any doubts are there, then please do ask me. Okay, already explained.
Yes, sir. Yes.
Okay, very good. Yes, let us move forward. Yes, very easy question. Please do attempt it. The percentage of seed uh, spacing that is less than or equal to half of the set plant distance is known as multiple index. Okay, quality field index, miss index, or performance index. Okay, please do tell me, what do you think? Percentage of seed spacing that is less than or equal to half of the set plant distance. Okay, what is the name for it? Yes, very nice, very good. It is multiple index. Okay, percentage of seed spacing that is less than or equal to half of the set plant distance is multiple index. Yes, term refers to the percentage of instances where seeds are spaced closer together than intended, specifically when the spacing is less than or equal to half of the set distance. Okay, means spacing x I have provided between two seeds, but the spacing has reduced by somewhat less, zero point 0.9x, 0.8x. So that are the instances of multiple index. Okay, then quality feed index I already explained you. Miss index I already explained you. Yes, performance index, it refers to a more general term that refers to various measuring of the seed mechanism's effectiveness, but is not specifically defined in this particular context. Okay, performance index can be, is a general term. Okay, not specifically related to our metering mechanism. Okay, yes. Yes, let's move forward. As per the BIS standards, the soil sample taken for measurement of puddling index has to be kept undisturbed for a minimum period of. See here, important keyword is there, minimum. Okay, minimum period is there. Okay, do attempt it. According to you, what shall be the minimum period for which the soil sample has to be kept? A or B, but you are not confirmed. Okay, no problem. Yes, according to the BIS standards, it is 18 hours. Okay, I'll tell you the term as well as the explanation in great detail. Puddling index, if you will see, this index measures the degree of puddling, okay, of the soil, often done in rice cultivation to create a suitable seed bed. Okay, puddling index measures the degree of puddling or the breakage of the soil clods into finer particles. The particular index is there for measuring what is the degree of puddling, how many number of clods are getting breaked. Okay, so undisturbed period is there. Okay, for that particular period you have to leave that particular soil sample. How I'll collect a soil sample, I'll just tell you in few more slides. Okay, after collecting a soil sample for puddling index measurement, it is necessary to allow the sample to settle or to stabilize. Okay, this settling period ensures that any water in the sample, if it is present, okay, it reaches equilibrium and the soil particles have sufficient time to settle. It is typically 18 hours according to the BIS standards. Minimum it is 18 hours. But for research point of view, we generally go for 48 hours. Okay, so that if some ternary soil particles are there, okay, of those soil particles which are having uh, very less velocity, they can also settle down. Okay, more about this in your soil mechanics course. Okay, what is the velocity of a particular particle, which is velocity of a particle, soil particle in uh, water soil interacted environment. There are more about that in soil mechanics course. But here the question was regarding puddling index. Okay, yes. So these are the methods which are used for puddling. Cage wheel is there. Okay, rotavator is there. Then power tiller operated rotary tool, similar to the cage wheel. You can see here a wheel is there. Okay, that is used for puddling, but the operation is happening from tractor instead of power tiller. Okay, yes. So these are the particular implements which are used for puddling of soil. Okay, puddling means destruction of the layer of the soil. Okay, this is the puddling. See here, this is infiltration rate measurement technique which is used for calculating the soil, for calculating the puddling index. Okay, puddling index is given by the formula Vs divided by Vt multiplied by 100. What you will do? You will take this particular hollow pipe, okay, insert vertically in the puddled soil. After the insertion, okay, top of the hollow pipe you have to close, and the pipe along the soil sample you have to remove from the soil, okay, from the puddled field, and that the collected soil sample has to be poured into a measuring cylinder. Okay, from the measuring cylinder you can only get these particular Vs and Vt. What was the volume of soil, okay, which has settled, and what was the total volume of the sample. Okay, so that will give you puddling index. Okay, yes. Is it clear? Information regarding puddling? Any doubts? Then please do ask me.
No doubt. Clear, sir.
No, no. Clear. Very good. Very good. Next question. Which type of mechanism is used in moving finger type self-propelled petty transplanter? Okay. Which type of mechanism is there? Is it rack and pinion? Is it slider crank? Is it cam and follower? Is it crank and rocker mechanism of 4-bar linkage? Any idea? Anything? D. Very nice. Very good. You are absolutely correct. It is crank and rocker mechanism of 4-bar linkage. Okay. Mechanism of moving finger type self-propelled paddy transplanter. Okay. This is the detailed diagram. I'll just zoom in for you. I think yes, it is clearly visible. Yes. See here, this particular mechanism is there, as well as you can do the kinematic analysis of the mechanism also. Don't get feared from the diagram. Okay, it looks a bit clumsy, but it is very easy to understand. Okay, I'll explain you in great detail. Just be with me. Yes, here you see crank is there. Okay, uh, with the help of pointer I'll show you here. See here, crank is there. Okay, rotational motion happens at the crank, then that is connected at point A through a coupler. Okay, then the coupler is connected to a follower. Okay, that follower is connected to another ring, and that ring is connected to this particular finger. HE is my finger. Okay, finger is HE. Here is also it is written. I'll also write HE is my ultimately finger. Okay. So what is happening here, when I am rotating my crank, then through the coupler the motion is getting transmitted to my follower. Okay, rotational motion is happening at the crank at joint A as well as at joint B, but you just try to see this follower that will also try to rotate that particular uh, ring. Okay, and that ring will ultimately rotate the pass the rotational motion to my finger. Yes, yes. Any query? You just raised your hand.
Can you zoom the diagram?
Yes, I can zoom it. No problem. Can you see it now?
Yeah.
Okay. Yes. See here, I'll tell you from the starting. Yes. See here, the crank is rotating. Okay. So rotational motion through joint A will get transmitted to my coupler. Okay. From the coupler, the same rotational motion will get transmitted at my BD attachment. That will further guide my follower. All the motion is rotational here only. Okay. So ultimately, the motion will get transmitted to my follower through my ring. Okay. Will get transmitted to my finger through my ring. And what will happen? See, a seeding tray is there. Okay. From this seeding tray, the seedling will be just plugged, or yes, plugged by my finger, and they would be sown in my puddled soil. Okay. At crank, rotational motion is happening. Joint A, it is getting transmitted to my coupler. Okay. From the coupler, that is ultimately transmitted to my follower, and that follower will guide my uh, finger. Okay. In rotational direction. Okay. What is happening here? It is just visualize this particular motion. Okay. This is my finger. Okay. So it will just plug and it will sew just like this. Okay. Just visualize it through my motion of my hand. Okay. So this particular motion will happen in case of my this particular seeding tray mechanism. Okay. This particular motion is for my finger. Okay. Not my hand finger, but the fingers of the paddy tray transplanter. Okay. I see this particular motion in this direction. It will happen. It will plug the seedling from my seeding tray, and it will sow in the soil. Okay. This was regarding crank and rocker mechanism of 4 bar linkage. Okay. Any doubts? Okay. Okay. That is all from my side. Just a quick clarification. Few seconds. Just 1 second. Yes, a quick clarification regarding my previous session. This was the question. Okay. Which was the following is not a type of soil covering device? Apologies from my side. I told correct option is scraper blade, but the correct option is gauge wheel. Okay. Please do remember it. Apologies from my side. There was confusion. Okay. Regarding option B and C. Correct option is gauge wheel only. Okay. Gauge wheel is not a soil covering device. Rest all the options which are given, drag chain, scraper blade, steel press wheel, these all are soil covering devices. Great explanation I have mentioned here. Okay. There was some confusion in the previous session. Okay. Apologies from my side and for it. Okay. Correct option is gauge wheel only. Okay. Just this information. Yes. Now coming back to our session. Yes. So the session is over from my side. Okay. If you have any doubts, then please do ask me. Okay. Else you can just kindly leave. Do join the session next week at the same time. Okay. Thank you for joining this session.
I
Okay.
have a doubt.
Yes, yes. Please do ask me. Yes, do ask me.
Can I share my screen?
Yes, yes. You can share your screen. I'll just unshare. Yes, I think now you will be able to share your screen. Yes. Okay.
Uh, are you able to see
Yes,
this?
yes. I am able to see your screen. Soybean is planted with a precision planter. Yes, yes. What is your doubt?
So I had a doubt. Here 3 into 5 by 18, and it is into 1 by 1.10.
Yes.
So so there was 10% skid. So I
Yes,
was putting
10%.
here 9 instead of 1 by 1.11. I was putting
Uh-huh.
here 9 by 10. Means 10% skid. Then 90% is the effective speed, I think.
Yes, yes.
But I think definitely I am wrong because the solution here is 1 by 1.1. So can you make me understand it is?
Okay, okay. I'll just explain you. Uh-huh. Please do continue. Continue.
Yeah, I was telling why I cannot write it here 9 by 10 instead of
Okay.
1 by 1.1.
Okay. I'll just tell you. Okay. Just a second. See here. What is happening? Two particular terms are there. First is slip. Another term is skid. Okay. When rotational motion is not happening, but translational motion is happening. Okay. That is what? Slip or skid? It's your doubt. That is why just I am asking you. What do you understand by this 10% skid? Any idea? According to you?
10% skid means I think at that time
Mhm.
rotational motion is stopped and only translational motion occurs.
Yes. So what effect it will have on translational velocity?
I
First
think
of all, your perception of skid and slip, that I have to just correct. Okay, what you just uh, told, that is slip. Okay, slippage. Sometimes we slip. Okay, on floor. Okay, so on that case, what happens? Translation happens, and no rotational slippage of a wheel. Okay, so that happens means rotational motion is not happening. Okay, but translational is happening. But in case of a skid, what happens? The rotational motion happens, but translation does not happens. So the entire effect on the translational velocity would be decrement of my translational velocity. Okay, so that is why in this particular case I have divided it by 1.1. Okay, or um, because the overall velocity is decreasing. Your doubt was why not to multiply it by zero point 0.9, right? Why we are dividing it by 1.1? Because of the efficiency. Okay, 10% skip means first, if the velocity was this much, 3 into 5 by 18, 3 kilometer per hour, now the velocity will decrement it. Either you can if you wanted to multiply it by zero point 0.9. Okay, but will not do so. Why? Because of the taking that term in efficiency. In that field efficiency question also we have done the same thing. I have told you to divide it by 0.85. Okay, not just multiplying it by 0.85. That is the same reason. Okay.
Okay.
Clear?
Yes, sir.
Do practice more, okay? While practicing only, you will be able to see that where I have to divide and where I have to multiply. Okay. Had the question been such that 10% losses are there, okay, the question here is, it is the planter is operated at 3 km per hour with a skid, 10% skid is there, okay, means decrement in translational velocity is there, okay. Had it been such that the planter is operated at 3 km per hour with a 10% frictional loss in the ground wheel, okay, 10% frictional loss, okay, then your perception would have been 100% correct. In that case, I have told you that 3 into 5 by 18 multiplied by 1 minus point 1 or multiplied by zero point 0.9. But it is skid. That is why you have to divide it by the efficiency. And that will be 1 by 1.1. Okay. That is the reason. Any more doubts? Anything?
No, sir. Thank you, sir.
Okay. 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 Join the session next week at the same time. Okay. If you are not having any doubts, then you can just kindly leave. Okay. Thank you for joining the session.